Entrancing than the overabundance, yet a current revelation has provoked a fundamental split between specialists as they take a look at the real factors now. The long-awaited revelation has appeared. Astrophysicist Neil deGrasse Tyson reveals the stunning disclosures in space, obliging us as we track how Adventurer 1 perceived 500 dark things going through space. Explore Tyson's examinations on this astounding revelation. On June 30th, 198, a stony space rock crashed into Earth, striking a city in Siberia, Russia. The solid impact of this event achieved the destruction of about 2,000 square miles. The huge meaning of this event reverberated globally, causing an overall shock wave. Following the investigation, it provoked the book, The Implied Agreement Between Cosmology and the Military, by Neil deGrasse Tyson, where he highlighted the association of coherent examination and public security, pushing for increased interest in space examination to protect our planet. This radiant work changed public care, enveloping the meaning of space examination. In an astonishing turn of events, NASA's space device Pilgrim 1 has distinguished 500 dark particles cruising by in space, leaving specialists confounded. Neil deGrasse Tyson, the widely acclaimed astrophysicist, has emerged to give essential clarity. However, as scientists delved into the mystery of these 500 unidentified things, they accidentally uncovered a superb revelation about Traveler 1 itself. But before we look at that divulgence, we ought to first get to know the amazing Traveler 1 space contraption. Adventurer 1, the brave space explorer, has traveled an astounding 1.45 billion miles from Earth. The speed at which the bus goes through space is surprising, covering a distance roughly 3.6 times the space between the Earth and the Sun each year. Yet there's more to the interstellar test than just its speed, stability, and distance from Earth. Voyager has sent a couple of significant revelations to us, like the new 500 dark particles it distinguished out there in the immensity of space. These are remarkable, brilliant things that we will not ever see, of course, but we will analyze that tremendous divulgence in a moment. But there is a question on your mind right now. How can a rocket that was shipped off way back in 1977 still be working and conveying such significant data? Well, the answer lies in the brilliant planning and foresight that went into Adventurer 1's arrangement. One of the critical secrets to Adventurer's life expectancy is its twofold redundant PC structures. Each Adventurer space device, including Adventurer 1, was outfitted with two sets of order PC subsystems, the Flight Information Subsystems, FDS, and the Attitude and Articulation Control Subsystems, AC. This redundancy served as a critical shield, allowing for steady changes among structures and the ability to activate dormant PC parts, thereby extending their future. The PC systems installed in Voyager 1 and its twin, Voyager 2, were arranged as a distributed structure with three twofold redundant arrangements of laptops. This redundancy guaranteed that if one structure failed, the other could take over, preventing urgent disillusionments. To use limited power sources, Pioneer units depended on planned reasoning, meaning the computers were arranged with modified configuration circuits to ensure they would be capable of functioning within power constraints and time limits during the rocket's journey. Power management is crucial to maintaining Traveler's operations. The rocket's distance from the Sun, where it can't harness solar energy, poses a significant challenge to power efficiency. Engineers had to devise innovative ways to check and improve power utilization. The power control framework used by this incredible man-made test is truly outstanding. One fundamental part of power management includes specifically shutting down non-essential systems. Designers carefully assessed which parts or subsystems were not central to the mission's fundamental objectives. For example, heaters associated with certain scientific instruments were deactivated. These heaters were initially intended to maintain the instruments at specific temperatures for optimal performance. By turning them off, power usage was significantly reduced, thereby extending the bus's general future. This decision to shut down non-essential systems isn't taken lightly. It requires a careful evaluation of the trade-offs between power conservation and the scientific objectives of the mission. Specialists work closely with researchers to ensure that deactivating specific systems does not compromise the quality and availability of scientific data. The goal is to strike a balance that maximizes power efficiency while maintaining essential functions. Furthermore, Pilgrim 1's power management systems adapt to the changing conditions of its environment. As the space device journeys further from the Sun, the available solar energy decreases. To compensate for this, Pioneer 1 adjusts its power usage accordingly. This flexible philosophy ensures that available energy resources are efficiently allocated to support primary tasks and data transmission over the long haul. Over the years, there have been continuous technological advancements and updates to the power management strategy, allowing planners to refine and optimize the power systems of the Pioneer tests. These updates include more efficient energy distribution, advanced battery charging systems, and improvements in power regulation and control. Thanks to these careful power management frameworks, experts have successfully extended Pioneer 1's operational lifespan, enabling it to continue its significant scientific endeavors through the universe. Since the rocket was initially expected to last for only 5 years, the fact that it is still sending back data nearly 50 years later is truly amazing. It highlights the determination and expertise of the specialists and designers who have worked tirelessly to keep Explorer 1 operational. Yet, despite this careful planning and execution, the vast quantities of valuable space data remain rare. Do not go anywhere, as a major revelation is coming. What did Adventurer 1 find that shocked scientists? While there are some expectations for what Wayfarer may first encounter, meteorites, asteroids, and space rocks, there is always the potential for unexpected wonders. One such surprising twist in Voyager 1's journey was the space contraption's case of recognizing 500 perplexing objects. This discovery caused a commotion and raised significant concerns among the specialists working on the mission. These peculiar signs and irregularities in the data came as a complete surprise. Adventurer 1 began conveying telemetry data back to Earth. However, the readings were strange, and there was no clear explanation for what was happening. The scientists initially dismissed this anomaly as an inconsistency. However, despite the unconventional transmission, Voyager 1 continued to follow commands from Mission Control, though with a slight delay in communication. This introduced a fascinating situation and deepened the mystery. What was particularly challenging about this irregularity was that it did not trigger Voyager 1's onboard fault protection systems. These systems are designed to activate when anomalies are detected, putting the rocket into a safe mode that allows experts to investigate the issue. In this case, however, Voyager 1 continued its operations without entering safe mode, adding to the intrigue. After thorough investigation, the anomaly was traced back to the Attitude and Articulation Control Subsystem, ACS. The ACS plays a crucial role in accurately orienting the rocket and controlling its movements. It was discovered that the ACS had been sending telemetry data through an embedded computer that had ceased functioning years ago. This old computer, which shouldn't have been involved in data handling, had somehow become entangled in the telemetry transmission process, leading to the corruption of the data being sent back to Earth. The mission then focused on fixing this inconsistency and determining whether there were indeed 500 dark objects out there. The solution involved retraining the ACS to redirect telemetry information to the correct functioning computer. This repair was considered low risk and was successfully accomplished. However, addressing this anomaly was not without its unique set of challenges. One of the most significant obstacles faced by the mission team was the enormous time delay in communication. Voyager 1 is currently located around 1.46 billion miles from Earth, an incredible distance. Consequently, it takes a substantial amount of time for radio signals to travel this vast expanse. When the mission team at NASA's Deep Space Network, DSN, sends commands to Voyager 1, they travel as radio transmissions at the speed of light. The DSN is an expansive network of large radio antennas strategically positioned around the globe. Its primary function is to establish two-way communication between Earth and deep space missions. The DSN collaborates with various space agencies worldwide, creating a unified effort to explore and investigate the mysteries of space. Communication with Pioneer 1 occurs through radio waves using the large antennas at these DSN stations. When sending information from the rocket to Earth, a frequency of either 23 GHz or 84 GHz is used on channel 18. On the other hand, while transmitting messages from Earth to Voyager 1, a frequency of 21 GHz is utilized. Despite the immense speed of light, even at this speed, it takes approximately 22 hours for a command to reach the bus. This time delay adds a layer of complexity to communicating with Voyager 1. The mission team must carefully plan and execute commands, considering the expected response time. Any errors or issues can result in unexpected challenges. During the anomaly investigation, this time delay posed a particular challenge. It meant that diagnostic and troubleshooting procedures were significantly prolonged. Commands had to be meticulously developed, keeping in mind the 22-hour waiting period before receiving any confirmation or response from Voyager 1. However, here's the striking part. Despite the significant time delay, every message sent to Voyager 1 was not just adding to the data, it was a crucial part of the mission. The time delay could limit real-time control and communication, but it did not diminish the importance of the communication. Each message was a vital piece of the puzzle in resolving the anomaly. Ultimately, the inconsistency was fixed at its source, and the faulty computer was shut down. Voyager 1, the great space application device, could then proceed with its remarkable journey through the vastness of space, sending back valuable data and insights to Earth. Now that we know the previous error of the space test has been settled, let's look at the outstanding accomplishments of the spaceship when it had no issues. The primary purpose of Voyager 1 and its twin, Voyager 2, was to conduct detailed studies of Jupiter and Saturn, including their rings and moons. Both spacecraft accomplished these goals with remarkable success, providing an unprecedented wealth of data and stunning imagery. One of the most iconic moments in space exploration history came when Voyager 1 took a family portrait of our solar system, which included the famous pale blue dot image of Earth. This image, taken from a distance of about 3.7 billion miles, highlighted Earth's tiny presence in the vastness of space. In the image, Earth appears as a tiny, pale blue dot suspended in a beam of sunlight. This photograph has become an enduring symbol of our planet's fragility and the interconnectedness of all life on Earth. The Voyager spacecraft has also achieved groundbreaking discoveries about the outer planets and their moons. Voyager 1 and Voyager 2 provided the first close-up images of Jupiter's and Saturn's intricate ring systems, revealing the complexities of these celestial structures. The spacecraft also discovered active volcanism on Jupiter's moon Io and explored the icy surface of Saturn's moon Enceladus, providing valuable data about the possibility of subsurface oceans.